In this video, we're going to be learning all of Calculus 1 in a single video, but in Minecraft, so that the retention isn't as bad. Let's jump right in. The four main pillars of Calculus 1 are limits, derivatives, application of derivatives, and integrals. Let's go into depth of each pillar. Limits are the first pillar we will talk about. There are two types of limits. Limits as x approaches a constant, and limits as x approaches infinity. Let's look over as x approaches a constant first. Here we have a limit as x approaches 1, x squared minus 1 over x minus 1. If we were to plug in 1 into these x values, we'd get 0 over 0, which is not allowed. To solve this problem, we have to factor out x squared minus 1 with x plus 1, x minus 1. X minus 1 and x minus 1 would then cancel, which would leave us with limit as x approaches 1, x plus 1. We now can substitute this x for 1, which would be 1 plus 1 equals 2. This is what this line would look like on a graph. This yellow line is the equation from earlier. At x equals 1, there is a missing block. That is because we've created a hole from the 0 equals 0 from earlier, because x cannot be 1. Therefore, the line is missing at x equals 1. Next we have up is as x approaches infinity. Here we have the limit as x approaches infinity, 4x squared over x squared plus 4. If we plug 0 into this equation, we get 0. If we plug 10 into this equation, we get 3.84. If we plug in negative 10, we also get 3.84. If we plug 100 into this equation, we get 3.99. Same with negative 100. If we plug 1,000 into this equation, we get 3.999. We seem to be getting closer and closer to 4, but we're not actually going to ever reach it. This is a graph of that function. As x increases, it gets closer and closer and closer to y equals 4. But if we zoom in, we're never actually going to cross over y equals 4. This line will get closer and closer to 4, but never cross over. Derivatives are the second pillar of calculus. Derivatives of a function find the slope of the function at a certain point. There are a few derivative rules to help you figure out what the derivative function is. The main ones are the power rule, product rule, quotient rule, chain rule, trig rules, and the log rules. F of x equals a function. F prime of x is the derivative of that original function, f of x. The power rule says to multiply the coefficient by the exponent, and that number becomes the new coefficient. And then subtract 1 from the exponent. If f of x equals 2x squared, what would the derivative be? Well, first we do the coefficient times the exponent, which is 4, and then subtract 1 from the exponent, so 2 minus 1 equals 1. This will give us the derivative of 2x squared is 4x to the power of 1, which can simplify just to 4x. The product rule is used when you have two terms that you need to be multiplied together. What you do here is you multiply the derivative of the first term by the second term, then add the first term multiplied by the derivative of the second term. So here we have f of x equals 2x squared times 3x cubed. First we take the derivative of the first term, 2x squared, which is 4x, times the second term, just keep it as it is, 3x cubed, plus the first term, 2x squared, keep it the same, times the derivative of the second term, and the derivative of 3x cubed is 9x squared. This is the derivative, but you can simplify it a little bit more, to 40x to the power of 4. The quotient rule is used whenever you have two terms that are divided by each other. This one has a fun saying to remember. Low d high minus high d low over the square of what's below. You can make a song about that. Low d high minus high d low over the square of what's below. Low d high minus high d low over the square of what's below. So here we have f of x equals 4x squared over 2x cubed. This means multiply the bottom term, 2x cubed, keep it the same, times the derivative of the top, 4x squared, which is 8x, minus the top term, keep it the same, times the derivative of the bottom term, 2x cubed, is 6x squared, over the square of what's below, which is 2x cubed squared. Then we can simplify it a little bit more, and a little bit more, and a little bit more. And f prime of x equals negative 2 over x squared. And don't tell your math teachers I told you this, but you can also simplify that to negative 2x squared to the power of negative 2. But I didn't tell you that. Next up is the chain rule. This is used when you have a term that has an exponent on the outside of the parentheses. And also when you have a derivative function with more than just one variable. But we'll skip that for now, and the rest of the video. In the chain rule, you'll have an outer function and an inner function. And the inner function is obviously the one in the parentheses, x squared. You can replace this with u. U equals x squared. You can now substitute x squared for u. Now this is just a simple power rule, 15x squared. You have to multiply it by the derivative of the inside, or u, which is 2x. Now you can replace u with x squared. So now it's 15x squared times 2x, which you can simplify it to 30x to the power of 5. And someone stole my train, so it looks like we're walking. Let's move on to the trig rules. For some complicated reason, the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. And the derivative of negative cosine is sine. And look at that, we're back where we started. In a continual, inescapable loop. In a continual, inescapable loop. In a continual, inescapable loop. In a So that means f of x, sine, is equal to f prime 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 of x. And there's also the other trig functions, but let's move on. Log rules are a bit more confusing. Well, sort of, until I figured them out one day and it just made sense to me. This log, natural log, and e. The derivative of a log function is the coefficient of the log function divided by x times the natural log of the base of the original log function. So here we have log x. F prime of x would be 1 over x ln 10, because 1 is the coefficient of log, which we didn't write because it's a 1, over what's in the log, parentheses, times the natural log of the base of the log, which is by default 10. So this is a really bad example, but the natural log. The derivative of the natural log function is the coefficient of the natural log divided by x. So 2 natural log x, f prime of x would be 2, the coefficient, over what's inside of parentheses, x. Also, the derivative of e to the power of x is e to the power of x. How simple. You wish all math were that simple, didn't you? The third pillar of calculus is optimization of derivatives. So we're taking what we have here and using it for real-world aspects. A lot of times people say, when will I ever use this math in my life? Well, I'll show you right now. You have been asked to build a fence by a farmer for his 10 cows. But you only have 64 fences. The farmer doesn't want his cows to be squashed together like those other guys. So you want to maximize the area inside of the fence so that the cows have the most space. And this problem, A will be area, P will be perimeter, L will be length, and W will be width. The formula for area is length times width, and the formula for perimeter is 2 lengths plus 2 widths. These are the formulas for a rectangle, not a circle. You can't have circles in Minecraft. So we have 64 fences, which is the perimeter. So that means the perimeter equals 2 lengths plus 2 widths. We can rearrange this so that 64 minus 2 widths equals 2 lengths. And then divide both sides by 2. So it's just length equals 64 minus 2w over 2. Which will be simplified to 32 minus width equals the length. Well, that's cool. Now we have the length side. But that's not a number. That's a variable with a number. Well, now we have area equals length times width. Well, we just figured out what L equals. L is 32 minus W times width. We can distribute that W, so the area equals 32W minus W squared. Now this is where the derivatives come into play. We want to take the derivative of this function, which is 32 minus 2 widths. Now we want to set 32 minus 2W equal to 0, and we get negative 2W equals negative 32, which we can divide by negative 2, which makes the width equal 16. Now we have how wide our fence should be. We can now go back to the perimeter formula. 64 was the perimeter, equals 2 lengths plus 2 W's. Well, we already know what 2 of those W's are, because we just figured it out right there, and we already know that we have 64 fences. This can simplify to 32 equals 2L, and dividing by 2 is 16 equals L, which is the length. So the length of our fence should be 16 fences, and the width of a fence should be 16 fences as well. And look at these conveniently placed markers. The width is 16, and the length should be 16. Now we can put Farmer Brown's cows in the fence. And now we have the most area we could possibly have with just 64 fences, unlike those other guys. The next pillar of calculus is can someone help me? Hello? Can someone come save? Hello? I was afraid it would come to this. The last pillar of calculus is integrals. Integrals are also called antiderivatives. F of x is the function, and big F of x is the integral or antiderivative of the original function. Integrals are literally just the opposite of this, so they should be pretty easy. There's two types of integrals, indefinite and indefinite integrals. If you remember from derivatives, f of x equals 4x squared, then f prime of x equals 8x. Well, if f of x equals 8x, then big F of x would be 4x squared, right? Wrong. The derivative of 4x squared plus 1 is 8x. The derivative of 4x squared plus 2 is also 8x. The derivative of 4x squared plus 3 equals 8x. The derivative of 4x squared plus 100 equals 8x. The derivative of 4x squared plus any number will also equal 8x. Any number is a constant, or c. The integral of 8x is actually 4x squared plus c, c being a constant to account for all of these extra numbers. And then there's the definite integrals. It asks us to find the definite integral of 8x from x equals 1 to x equals 2. F of x equals 8x. Big F of x equals 4x squared plus c. The c doesn't matter here for some reason, so 4x squared on the domain of x equals 1 to x equals 2. We can replace x equals 2 with this original function, which equals 16. We can also do that with 1. And we can subtract 16 minus 4 equals 12. Definite integral of 8x from x equals 1 to x equals 2 is 12. And that's Calculus 1, but summed up in one Minecraft video. Next week I start Calculus 2. At the end of the semester I'll make another video of Calculus 2, but in a Minecraft video, so the retention isn't even worse than last time. Thanks for watching.